Hello, everyone, and thank you for joining our session, Are Microgrids the Future for Sustainable Data Center Operations? This is the third webinar in our Data Center Sustainability series. My name is Rachel Emanuel, and I am today's moderator. Before we begin, let me highlight some features of this webinar platform. There is a Q&A panel to the right of the slides. During the presentation, you can submit questions at any time by entering them here. Our speakers will address as many as possible at the end of the presentation. You will receive an email later this week with a recording of this presentation and a copy of the presentation material. This is a 5-part series covering sustainability trends and innovative technologies that support reliable data center operations while consciously managing environmental impact. Upcoming sessions will run in 2-week intervals through the middle of June. You can find the registration link to sign up for the remaining webinars in the reminder email you received for this session. Your speakers today are Gary Rackliffe, Vice President of Market Development and Innovation for Power Grids, and John Glassmire, Senior Advisor for Grid Edge Solutions at ABB. Now I will turn it over to Gary.
Great, thank you, Rochelle. So what I'd like to do first is just start off the meeting with a brief safety moment. And I think with a lot of us working at home, given the COVID-19 pandemic, I think it's important to also make sure that you still practice or apply best practices for safety, even if you are working remotely in your home. You need to keep safety as a top priority. So maintain a safe working area. Be aware of the safety procedures that you need to have in place for a home office. I have a new challenge. My wife's dog, which is an 80-pound lab, likes to park itself right beside my chair and take a nap, which presents a tripping hazard every time I get up and leave my office. But I think just be aware that safety is still important in the home. For anybody on the webinar who's on the go and not in their office, either the regular office or a remote office, ensure that you're at a safe, stationary location for the duration of the webinar. Don't put others at risk or yourself by trying to listen in or participate while you're driving. And then as for your health, I think it's important. Do not become complacent regarding the threat of COVID-19. We're seeing states starting to reopen and lift restrictions as part of the phase 1 and phase 2 recovery. But I think it's very important to follow the guidelines to protect your health and your family's health. So I'd like to start off the webinar with the section that we have on sustainability trends. And these are just some of the key trends that we see both globally as well as what we see in the U.S. If we look globally in the last year, energy demand worldwide grew by 2.3%, which is the fastest pace this decade for global energy demand. And as a result, global energy-related carbon dioxide emissions rose by 1.7%. In the U.S., we have seen flat electricity demand, but as we look out towards 2050, we expect to see about a 50% increase in electricity consumption. Part of this is related to electrification of transportation, which by itself could drive a 25 to 38% increase in electricity consumption, which was the forecast by NREL, the National Renewable Energy Lab outside of Denver. We see data centers being a significant load to the grid, but also we see productivity improvements, which lessen some of the impact to the grid in terms of demand. We're seeing a shift to more renewables. We expect to see wind and solar be approximately 50% of the generation mix by 2050. We see connected IoT devices going up by more than an order of magnitude, from 40 billion to 500 billion. As I mentioned with electric vehicles, we expect to see growth in electric vehicles and see as many as 250 million EVs on the road by 2030. Climate change is still driving a lot of sustainability issues for major corporations, and we'll talk about data centers and specifically. Population is continuing to grow from 7.8 billion to 9 billion over the next 30 years. That still leaves 1 billion people without reliable electricity. And then we're also seeing an increase in urbanization with a growth of 50% of the population to 70% of the population. So this chart shows the U.S. energy consumption, and it shows the primary energy consumption, which has basically been flat. But at the same time, we've been able to grow economically. So our GDP is increasing, but our primary energy consumption is flat, which means our energy productivity has been improving over the past roughly 20 years, which makes us more efficient. This economic growth may be derailed by COVID-19, but the economy is expected to recover, although we're not certain of timing. But we do expect to see these trends continue. This particular chart shows the PUE for data centers. And that's basically the power usage effectiveness. This is the ratio of total amount of energy used by the data center to the energy delivered to the computing equipment. Basically, it's the inverse of the data center infrastructure efficiency, which is also called the DCIE. According to the Uptime Institute, data center PUEs have dropped from 2.5 in 2007 to 1.58 in 2018. The industry did see an uptick in 2019 to 1.67. And there's several factors which basically, I think, explain the change. The two biggest factors, we had higher temperatures, ambient temperatures last year, which impacted cooling, requiring more cooling for data centers. And also we're seeing some drops in data center utilization as the workload moves to the cloud and to more efficient data centers from corporate data centers. The upward tick is expected to be temporary based on the PUE values ranging from 1.1 to 1.4 for the hyperscale data centers and the new highly efficient co-location sites. So this particular slide just shows the contributions by economic center to greenhouse gas emissions. And on the left, you can see the global numbers. And then on the right, you can see the US numbers. So on the left with the global breakdown, you can see that electricity and heat production is a quarter of the greenhouse gas emissions. Electricity on the right-hand side for the U.S. is 27%. So any pathway to greenhouse gas emission reduction will have to address power generation. Also in the U.S., transportation is equally important. So both of basically these two sources of emission have triggered the industry focus, and I mean by industry, I mean electric power industry, focus on carbon-free generation and also the electrification of transportation. Again, if we are to meet goals for greenhouse gas emissions, we have to be able to reduce the emissions from our generation of electricity and then also the transportation. This chart shows, this is a chart from SEPA, which shows that U.S. utilities and also the states are stepping up to address clean energy goals and to address greenhouse gas emissions. This particular slide shows the service areas for utilities that have announced clean energy goals. The shaded areas represent about 70% of U.S. customers. To generalize, these goals typically are carbon-free generation by 2050. Now, carbon-free gets interpreted a couple of different ways. Some utilities are saying 100% renewable generation. Other utilities are saying carbon-free, meaning nuclear, hydro, and renewables. And then others are saying net carbon zero. And then some of the timelines are more aggressive than 2050, but I would say the most common target date is 2050. Also in parallel with the generation, as I mentioned, utilities are implementing plans to supply the power to EV charging infrastructure to support electrification of transportation. This next slide shows the generation mix. So on the left, you can see the generation mix, power generation mix globally. And then on the right, you can see what the U.S. generation mix has been for the past 6 years. For comparison, the U.S. is, it follows the global trends fairly closely. You can see that basically our carbon-based generation, natural gas and coal, is about 60% of our generation mix. And then our carbon-free, which includes nuclear, and then the blue at the top of the chart, which is renewables, including hydro, is approximately 40%. Again, the U.S. is targeting, now with several utilities having made these announcements, to be 100% carbon-free by 2050, which means natural gas and coal, representing 61% of our generation mix, will need to be retired by 2050. So we have 30 years to make this pretty dramatic shift in our power generation mix. The global trend for renewable investment, this is data from IRENA, the International Renewable Energy Agency, and this chart shows solar, wind, and other green technologies are actually IRENA has, this is another report, IRENA has reported that solar, wind, and other green technologies now provide more than 1/3 of the world's power. Again, for the U.S., the carbon-free generation mix that we had last year was about 40%. So we're a little bit ahead of the world overall. The majority of new generation investment is renewable, mostly wind and solar. And this chart shows that over 150 gigawatts of renewable generation capacity has been added each year for the past 4 years. I think one of the main drivers, in addition to sustainability, is that the price has dropped. Auction prices for utility scale, onshore wind, and solar PV have dropped as low as $20 per megawatt hour. And again, these are open auctions for the generation component. This slide shows the generation investments. This again is showing gigawatts of generation investment or capacity investment for all sources of generation. What's interesting on this, over the past 25 years, over 90% of generation investment in the U.S. has been either natural gas or renewable generation. You can clearly see the trends with natural gas peaking units being added to the grid in the time frame from the year 2000 to year 2005. On this particular chart, the gray color is natural gas. And then you see the growth of renewable generation, which is shown in the blue, starting around 2006 or so, and then continuing to grow to the present. So this chart is the breakdown of renewable generation investment by the type of investment, by the type of, or the source of the generation. It's mainly wind, which is shown here in the blue, and solar, which is shown here in the yellow. I think a couple of things that are important to note. One is, if you look at the investment in 2012 and 2013 for wind, again, which is shown in the blue. This points out that public policy really matters. In this case, the public policy was the wind production tax credit, which expired at least for the year of 2013 before it was reinstated. And you can see the big surge of investment in 2012, knowing that the production tax credit was going to expire, and in the small amount of investment in wind generation, which occurred in 2013. Based on cumulative capacity, this shows actual investment by year, but cumulative capacity, wind and hydro production are now nearly neck and neck, accounting for 37% and 39% of total renewable output, respectively. The balance is primarily solar PV, which we can see based on the investment trends over the past 4 to 5 years is catching up with wind and hydro. This particular slide shows the renewable energy purchases in terms of capacity in 2019. And clearly Google was the leader with just in the past year procuring 2.7 gigawatts of renewable energy capacity in last year alone. So we see all the tech giants, you know, Google, Facebook, Amazon, and Microsoft. And these companies are emerging as the biggest buyers of renewable energy to help power their data centers. And tech firms bought almost a quarter of the renewable energy sold to global companies last year. Bloomberg New Energy Finance found that 100 companies in 23 countries struck deals to buy this 19.5 gigawatts of renewable energy last year, which is up 40% from the previous year. These are primarily power purchase agreements, likely to have cost between $20 and $30 billion, and making up about 10% of the world's total renewable energy investments in 2019. If we look at the top 4 companies, tech companies that have data centers, we can see that Google. This is information that I pulled from each of the sustainability reports for these 4 companies. But Google has been purchasing 100% renewable energy for the past 3 years. Facebook is committed to reducing its greenhouse gas emissions footprint by 75% and reaching 100% renewable energy by 2020. Amazon plans to be net zero carbon by 2040 and reach 80% renewable energy by 2024 and 100% renewable energy by 2030. And then Microsoft will become carbon negative by 2030 and then plans to offset all the carbon emitted by the company since it was founded and complete that task by 2050. This is showing Google's energy consumption on the left, and the fact that they have reached 100% renewable energy for the electricity use that they have across their operations. And then on the right is showing the cumulative capacity of Google's renewable energy portfolio. And you can see the big jump that has occurred from 2018 to 2019. And Google is clearly the leader in securing renewable energy generation. Basically, the Google CEO, Sundar Pichai, posted a recent blog that said, "We're not buying power from existing wind and solar farms, but instead are making long-term purchase commitments that result in the development of new projects. Bringing incremental renewable energy to the grids where they consume energy is a critical component of pursuing 24/7 carbon-free energy for all of our operations." He continued to say, "Up to now, most of our renewable energy purchases in the U.S. have been wind, but the declining cost of solar has made harnessing the sun increasingly cost-effective." The next slide shows what Microsoft is doing. So in the blue, you can see the carbon emissions from Microsoft and its supply chain. And then in the green, you can see where they've been offsetting that with renewable and avoided emissions. And they expect to reach carbon negative by 2030, which can be seen on the right-hand side. And then as they move forward to 2050, the green shown at the bottom, which is the carbon removal, will continue to offset annual carbon emissions, plus offset the area under the dashed line, the blue area that's under that dashed line. And that's the announced goal that Microsoft has released in their sustainability report. So clearly a focus on carbon reduction, but also carbon removal. I included this slide in the deck because, I talked a little bit about greenhouse gas emission reductions, sustainability, reducing carbon footprint, and, there are good societal reasons behind the sustainability goals and drivers. But also there's an economic driver, which is the cost of these resources is decreasing. So not only is it good for the environment, good for society, but it also, there's not an economic penalty. In some cases, there's economic benefits to moving to renewable generation. In the next section of the presentation, John's going to be talking about grid edge solutions and microgrids. And battery storage is a key technology. And we have already seen an order of magnitude decrease, or nearly an order of magnitude decrease in lithium-ion battery storage prices since 2010, moving from around $1,000 per kilowatt hour to $100 per kilowatt hour. So the batteries for electrification of transportation are clearly helping to drive down the cost of battery energy storage. And we're seeing grid applications include solar plus storage behind the meter, storage to reduce demand charges for commercial and industrial applications, storage for resource capacity firming, spinning reserve, asset deferrals, black start, which are some of the grid services that storage can provide. But clearly, the economics are becoming more and more favorable towards the renewables and also the application of lithium-ion battery energy storage systems. There's been a recent announcement, I believe now, I think the largest battery energy storage announcement that I've heard is approaching 400 megawatts. So we're seeing tremendous growth in the size of battery energy storage systems. So this is my last slide before I transition over to John. So this slide shows the different levels of the grid, the types of generation and the deployment of energy storage. Although pumped hydro storage today represents about 90%, or actually I think it's 93% of U.S. storage for electricity, the bulk of the new storage deployments are battery energy storage systems. And in the U.S., we also see that data centers are connected to the grid at the distribution level, the medium voltage level, or sub-transmission level, and then also at the high voltage or the transmission level. We can see storage is deployed across the grid at all levels. And data centers represent a significant load to the grid, but with grid edge solutions, data centers can also be part of the solution going forward. So what I'd like to do now is turn it over to John, and he's going to cover what are grid edge solutions and why data centers. So let me advance this. And I'm turning it over to you, John.
Thank you, Gary, for setting the stage for the trends across the electricity sector that are going to shape how data centers can manage their portfolios and participate in the new energy ecosystem. So, the trends that Gary described are leading to, as I say, a new energy ecosystem and a dramatic shift in the electrical value chain. So one of the key changes is that by 2035, we're expecting a renewable share of more than 40% of the total global capacity. So while I view this as a good thing, it does mean that the generation mix will include sources that are less predictable and also more distributed, meaning feeding in at more locations across the networks, the electrical networks that connect us all. So from the perspective of the utilities that run the transmission and distribution systems that deliver our electricity, this means increased complexity and increased need for smart controls, automation based increasingly on larger and larger amounts of information that will be necessary to balance the flow of electricity, make sure the supply meets demand. So under this future, our electricity will become essentially both from further away as we import renewable energy from more distant areas through the transmission system like Gary described, as well as locally as we increase the amount of renewables in the distribution networks that feed our homes, businesses, and in the context of this talk, data centers. So the growth of local generation and distributed energy resources will require this control and specifically optimization at the local level to ensure we extract the maximum value from those distributed energy resources like solar photovoltaics and battery energy storage systems. So this provides an opportunity for data centers to define what they want to achieve, both in terms of how they use renewables as well as more broadly in their stability of their and reliability of their electrical supply. So as we transition from this more vertically integrated power generation with the centralized power generation, we're going to move to a more networked type approach with a bidirectional energy power flow, where consumers like a data center can become a prosumer, meaning that they're participating in the energy economy. So this is happening due to the technological innovation and cost reductions in the technologies that Gary spoke about, which in turn is enabling and requiring new business models. So as we increasingly move to a grid operated more like this mesh, we're getting even more connected through our electrical network. This enables these new distributed solutions to extract more value for utility customers, as well as new opportunities to ensure power grid stability and customization of renewable portfolios. So to achieve this, grid edge solutions and microgrids will play a big role in the power grid of the future. So with that sort of segue background, let's clarify sort of two questions that you're probably thinking about. What is a microgrid? And then what are grid edge solutions? So let's start with a microgrid. A microgrid refers to distributed energy resources, such as solar PV, batteries, or even conventional generation, together with the loads that connect to the main power grid. So they can connect to the main power grid, or they can really critically operate in an islanded mode, meaning autonomously from the rest of the utility network. So with grid edge solutions, these microgrids can be operated in a controlled and coordinated way and can seamlessly transition from this grid support mode, where it's interacting with the utility, to be completely off-grid with secure, reliable power, ensuring continuous operation for the critical loads in a data center. So, grid edge solutions really are a broad suite of solutions in a package. So they're a critical technology for microgrids, and they're ultimately the technology suite that makes microgrids. When people talk about microgrids, it's the grid edge solutions that make them an attractive concept broadly, as well as specifically for data centers. So given the audience here, I would say you can think of grid edge solutions much like the electrical system equivalent of, you've probably heard the term edge computing, that I know has been a really common topic of discussion across the tech industry. So with grid edge solutions, similar to this edge computing, we see control of electricity moving from centralized to decentralized. A grid edge solution can be a microgrid itself, or you can equip a microgrid with these grid edge solutions to make it an advanced technology that supports what you want to achieve. So grid edge solutions include the on-site connected devices, such as the on-site power generation, energy storage systems, and I think the key key piece here is that it's enabled by advanced control and digital automation. That's the magic of what makes this happen from a technological perspective. The grid edge solutions can unlock the benefits of not only the supply side of things, but also the load management. So it can incorporate flexible loads, things like strategic dispatch or management of your on-site electrical vehicle chargers. So if you have an electrical vehicle fleet, you can manage that through a grid edge solution, or through integration with other existing management systems like building management systems that are likely to already be at the data center, or the data center infrastructure management system. It's that tight coordination that allows you to manage all of the loads in concert with your local distributed generation and in concert with your relationship with your utility. So grid edge solutions can be deployed quickly and easily, and they provide not only this coordination, but also things like demand response capabilities. So if your utility has a demand response program, you can participate in it. Energy optimization, so making sure you're using everything to the greatest potential, as well as things like monitoring and reporting that can show how your individual site is operating, as well as an aggregate portfolio of these sites are operating together, and then put those together in what's called a virtual power plant so that you can stack them together and participate in energy and ancillary service markets. So with that introduction to what a grid edge solution, how it relates to this microgrid concept, let's talk specifically why grid edge solutions for data centers. So essentially, with a grid edge solution, you enable the data center to become a smart data center. So for example, if you wanted to lower your CO2 emissions, you can do that by increasing on-site as well as remote renewable power integration. So the grid edge solutions really maximize the value of that renewables, which can then reduce the operation if you're doing them locally, reduce the operation of backup power generators. So in other words, limiting the need to burn costly and environmentally damaging fossil fuels. They can also increase the operating reliability, which is sort of there's the short-term interruptions that I know are a real challenge for data centers. It can help reduce that, as well as provide a resilience solution where they make the electricity supply more robust and able to support longer operation. Having that islanding capability really does help you decrease your dependence on the utilities and increase data center uptime. They can also stabilize the electrical grid through key things like improving power quality, strengthening the voltage frequency regulation, or managing reactive power and the voltage response. So you're getting really, really high quality power that is critical to the operation of these data centers. And as we'll talk about soon, it also enables better use of renewables. Higher power quality equals better use of renewables. And finally, it's also a set of solutions that put together can reduce overall energy costs and provide opportunities for new revenue. So essentially, by optimizing all these resources, it lets you, for example, participate in energy markets that you may not otherwise be able to. So now let's have a look in a little bit more detail about how you might implement a grid edge solution at a data center to make it become a smart data center. So a smart data center would be located near an on-site or local renewable power generation. So this might be, say, solar on the roof of the data center, or maybe nearby on ground mount, as well as potentially wind power generation if you're near a good wind resource. So when you equip the data center with these grid edge solutions, which include things like battery energy storage systems, advanced real-time control, and then critically the energy management, which is the way you optimize these things, you'll be connected to the main grid through a point of common coupling with the rest of the utility system. And this point of common coupling of the data centers typically at the medium voltage level and would then be located near to it. Everything on one side has the enhanced reliability and enhanced coordination of the grid edge solutions. Everything on the other side is on the utility side of things. So with this real-time control, advanced control, we're able to control the import or export of electricity to the data center from the utility. And this is done according to commercial or technical conditions that can be customized based on the needs of the data center and in coordination with local generation and other distributed resources. So with this real-time control, the data center's grid edge solution energy management system will manage the data center power production as well as the load demand in coordination with existing energy management strategies and solutions. So a key piece here is you're able to look ahead and leverage a day-ahead forecast, which is really important when you have things like renewables, where you need to know, well, is the sun going to shine? Will the wind be blowing? This day-ahead forecast is really important because it helps you appropriately manage and align the operation of energy storage assets. Essentially, you want to make sure the batteries that you're using to provide your reliability and integrate renewables are at the right level of charge so they're ready for whatever is coming. And this optimization is possible with artificial intelligence, that you can optimize how that data center gets and uses its energy in real time. And if you're having to, if you're having issues with the utility, for example, if there's a utility disruption, so there's some sort of power outage, this would prevent that and make sure that you have that seamless transition while ensuring that existing backup assets, traditional backup assets like diesel power generators, do not need to be switched on. So I'll also note that grid edge solutions can be used to manage a battery energy storage system to enhance grid code compliance for renewables, as well as participation in the ancillary services market. So for data centers, I know there's this idea of local, but it's also, I know a lot of data centers are using remote renewable power generation. So it's an enabler there that allows the data centers to make sure that they're maximizing the use of renewables that may be offsite, as well as data centers that host the renewables locally. And one of the key things of this is with the appropriate monitoring enabled in the solution, it provides full visibility of your asset performance so that you can track how much renewables you're using, as well as information about how much carbon emissions or CO2 emission reductions you're able to take credit for. So let's talk through some of the specific key values that I think are important. And those are maximizing the value of renewables, increasing resilience, stabilizing your network, and unlocking new revenue opportunities. So on this slide, we're going to focus on the first of those two. So let's talk about maximizing your renewables. So as you've seen from the stuff that Gary presented, renewables are the future of our energy supply. However, as you add more renewables like wind and solar to the grid edge solutions become increasingly necessary to ensure that you get the maximum value out of those assets. You don't want to be curtailing them. So the grid edge solutions prevent this need to curtail or limit what you're getting out of them that could otherwise either serve the data center or another network customer. And critically, many renewable sources, particularly wind and solar, will need support from grid edge solutions if there are issues with the utility network. It provides that way for them to continue their operation and reduce curtailment. And if it's local renewables and there are problems with the data center's utility supply, grid edge solutions can step in and take the value of the renewables further, enabling the data center to use the renewable energy to not only improve how much is pushed out to the grid, but also use that renewable energy locally, reducing fuel use when that the data center needs that backup. Without this, the renewables cease to produce. You have to, without an appropriate grid edge solution, typical renewables will stop production. You need the grid, either the grid up or you need a grid edge solution locally to ensure that your renewables can continue to produce. So ultimately, this reduces the cost and environmental damage from fuels used for backup. That's about a little exploration of how grid edge solutions can impact the renewable usage. Further, grid edge solutions provide benefit during utility grid outages by increasing the resilience of the power supply for data centers. So in addition to reducing backup fuel requirements by as much as 50%, you'll have additional operational flexibility, an ability to ride through longer outages, even if there is difficulty. So for example, if you have difficulty getting in fuel supply while you're running your data center in backup operation from the utility, it can extend the ability for your data center to continue operations, adding that flexibility. Further, the grid edge solutions not only offset fuel usage, but they can enable you to completely switch off your generators. An appropriately configured grid edge solution lets you operate entirely from renewables if you want, because they can be used to provide what's known as spinning reserve. That is a key service that backup generators often provide. Additionally, and this should be somewhat apparent, but the battery energy storage system in a grid edge solution provides a new storage asset at the site. So that provides a further direct backup support to, say, existing UPS or backup generation. And together, these support reliability and resiliency, driving the data center towards its ultimate goal of 100% uptime. I know you may hear the term 5 nines or 4 nines or 6 nines, meaning pursuing that 99.999% uptime. This gets you closer to your ultimate goal. Let's move on. Now we've seen grid edge solutions can maximize the value of renewables and increase resilience. Let's talk about stabilizing the power supply and unlocking new revenue streams. So if you want to power your data center with renewables, you'll need that grid edge solution to stabilize your supply. So the challenge with operating renewables is that how they're connected to the grid. Often through, most renewables use what's known as a grid following inverter. And what you need in the mix is something to supply the grid that they will follow. So the ABB's grid edge solutions include an advanced high power grid forming inverter that supplies that grid so that renewables can continue to provide their energy for data center operations. At the same time, this advanced technology, coupled with smart automation and digital control, improves the power that's delivered to the data center, improving voltage, frequency, other power quality metrics. Finally, grid edge solutions enable a smart data center to participate both in energy and ancillary service markets. So this provides a new revenue stream to help cover the costs of the investment in a grid edge solution. And it's not just a revenue stream. I know there's a lot of talk about data centers being good citizens, good corporate citizens, and enables the data center to support the utility grid, provided much needed services for the utility network, supporting the utility's transition to renewable baseload generation. In other words, grid edge solutions enable the data center to make money while being sustainable. So let's summarize the services that grid edge solutions will provide to a data center. There's resiliency and islanding, power quality improvements, peak shaving and load shifting. This is another way to say reducing energy bills. Demand response, which is a revenue source, depending on the terms of your relationship with your utility through the data center. Maximizing independence and self-consumption, and enabling energy market participation, energy and ancillary service market participation. So I mentioned earlier a grid edge solution energy management system. How might that work at a data center? So if you're an energy manager or an operations and maintenance manager at the data center, it's important to know how your local assets are operating and how they'll be used in the coming day. Grid edge solutions can help you with your equipment maintenance, planning, and needs, as well as gaining insight into how things are operating and how they're being used, as well, and the life cycle costs of those assets. So with an ABB eMesh solution, it's possible to have full visibility of the daily energy management optimization cost savings, the renewable power generation, CO2 emissions, unlocking and opening up so you have transparency around the operation of these assets and other contributions that your data center is making in terms of renewables and sustainability. The grid edge solutions also from ABB also support cloud-based monitoring, so remote monitoring, so that you can provide data center owners full visibility both on and off site with detailed information and aggregated overall power generation capacity. Whether you're remotely managing one data center or 10 data centers, you can pull those together to get full coverage anywhere about all of these great contributions that your grid edge solutions and your data center microgrids are having. And finally, what I'd like to leave you with is that ABB has been working with grid edge solutions for almost 30 years. We have an extensive experience with these, and our global footprint of more than 500 megawatts of battery energy storage, microgrids, and more than 200 references. We've been a pioneer. We are a pioneer in the deployment of these systems, as well as the energy management and optimization. And we're looking forward to the future, leading in energy innovation and the transition. So our goal is to support our customers to increase profitability and unlock new revenue streams, help them maximize the renewable integration, maximize the value of their renewables, while lowering CO2 emissions and improving the overall power grid's reliability and resiliency. With that, I will close and see if there are any questions.
Thank you, Gary and John, for the thorough background on the energy trends and the explanation of microgrids and grid edge solutions and how they can be applicable to data centers. We are currently at the end of the time we have for today, so we plan to follow up by email to any questions that were sent in during this session. When you all exit the session, you will be prompted to fill out a survey, and we would appreciate any feedback you have on today's event. Thank you again for joining, and we hope to see you in a couple of weeks for our Digital Data Center Operations webinar.